So now let's go ahead, give ourselves a brain break, and let calculators do the work. Okay, so for this set of questions, we're using a calculator and we're going to round to 4 decimal places. So the first thing I want you to do is just find the log button on your calculator. So I'm looking at my calculator right now. It's kind of in my second row up from the numbers, and I'm going to hit log, and that's an assumption that it's log base 10. So this is actually saying 10 to what exponent is going to give me 645. So if I type in log of 645, I get 2.809, and then we're rounding the 5 because it goes 5, 5. We're going to round that 5 up to a 6. What that means is if I wanted to check this, if I typed in 10 to the exponent, and actually I have a button, if you notice my calculator anyway, I have a log button, and then above my log button, I have a 10 to the x button. So if I just hit second function log, I get 10 to the, if I type 2.8096, I get 645. Now, not perfectly because I rounded, but close enough. So then what if I type in log of 0.0239? I get, ooh, weird, a negative number, negative 1.6216, which means 10 to the negative 1.6216. So 10 to the negative 1.6216 is equal to 0.0239. Does that make sense? Do I get a fraction or something less than 1? Yeah, well, because I'm negative exponent, this is 1 over 10. So 1 divided by 10 to the 1.6216 would give me this less than 1 number. Okay, let's try the next one. What about log of negative 3? Log of negative 3. My calculator says error. What does your calculator say? Hopefully error. 10 to what exponent would give me negative 3? Well, I have a positive base. A positive base raised to any exponent is going to come out positive. So even when I had a negative exponent like negative 1.6216, it came out as a positive number, something greater than 0. So I can never take the log of a negative number because I can never make a positive base into a negative number. So for this one, we could just say does not exist or something along those lines. All right, and then what about the log of 1? What happens if you type log 1? I get 0. Is that the answer? Well, let's think about it. 10 to what exponent would give me 1? Well, 10 to the exponent 0 is 1. Anything to the exponent 0 is 1. All right, let's move to the natural logarithm. So this is no different, except this one it's saying e to what exponent is 645. So you're going to get a totally different answer for x. So for this one, if I type in ln, which on my calculator is the number next to log, or the button next to log, of 645, I get 6.46925. So I'm going to round that 2 to a 3. That's it. So e to the exponent 6.4693 would give me approximately 645. What am I expecting for this number less than 1? Hopefully you're expecting a negative answer. So ln of 0.0239 is also negative. It's negative 3.733 and then 87. So I'm going to round that 8 to a 9. And then what about ln of negative 5? Well, could e, which is a positive number, 2.71, blah, 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 could that ever equal a negative? No, does not exist. And lastly, what about the ln of e? First off, how would I plug that in? Well, I'd type ln, and then on my calculator, I need the e to the x button, which is above my ln button. So I'm going to hit second function ln, which gives me e to the, and then I'm going to type a 1 in there, right? So for me to get it, I have to go ln of e to the 1. And if I type that in, I get 1. Log base e of e. This is saying e to what exponent would give you e? Oh, the answer is 1. So this is kind of an important thing, right? Anytime you take the log of 1, no matter what the base is, you always get 0. And anytime you're taking the log of the base of that same base, it's always equal to 1. So it's kind of a general rule to know. I used to have in the notes that it was a rule. I'd rather you just explore it, right? So log base 5 of 5 is 1. Log base 3 of 3 is 1. Log base 5 of 1 is 0. Log base 3 of 1 is 0, right? Just a general thing. And then the last thing we're going to do before we leave this is just what about if I asked you to take log base 5 of 8? So there are fancy calculators coming out now that you can actually set your base. So you could type in log, I want base 5 of 8, and that's all cool. But there is a way around it. And the way around it is called the change of base formula. Okay, this is the change of base formula. Log base b of m can be written as the log base anything of m over the log that same base of b. So what you're doing is you're taking the log of b, or sorry, the log of m, and dividing it by the log of b, and then you could put whatever base you want in there. So for example, if I wanted to solve this guy, I could do log, I'm going to use the common logarithm, so I'm going to use base 10. I'm going to do log base 10 of 8 over log base 10 of 5. And I'm going to type that into my calculator. So log of 8 divided by log of 5 to 4 decimal places gives me 1.2920, which means 5 to the exponent 1.2920 should give me 8. Well, let's check it. 5 to the exponent 1.2920 is 7.9996 because we rounded. Okay, so that's what this change of base formula does. Is it allows us to plug in something other than a base 10 or a base e. Now, excuse me, just to show you, we could use any base. So let's use the natural logarithm because that one we also have in our calculator. So instead of putting this as log base 10 of 8 over log base 10 of 5, let's do this as log base e, or ln of 8, over log base e, or ln of 5. So just quickly plug that in your calculator. Ln 8 divided by ln 5. Oh, look at that. 1.2920, because it doesn't matter what you choose as the base, as long as it's the same top and bottom, right? You couldn't do log 8 divided by ln 5, right? It has to be the same. So prove this to yourself. Do the next one. So I want you to do the common logarithm up here, and then the natural logarithm down here, and evaluate log base 2 of 13. So log base 10 of 13 over log base 10 of 2 gives me 3.7004 ln of 13 divided by ln of 2. Ln 13 divided by ln of 2 also gives me 3.7004. Awesome. All right, go practice with your calculator. But don't forget what they mean, right? This one is 2 to the exponent 3.07004 is approximately 13, right? That is what a logarithm means.